Hi guys, welcome to with Hackathon 2022. This is Fantastic Four, and our team contains Sakurukundan Srinivas, Sekshamika Tamal Sautabazum, Pablo Mukesh Narayana, Danush Kumar. Now, first comes our problem statement. Our problem statement says that water is a basic necessity of every human being, but water is a scarcity is a major issue that is raised very rapidly in India nowadays. The problem has become so severe that in many states the groundwater has almost dried up, and people have to depend on water source supply for the sources. In addition, water is one of the most misused natural resource that is still being wasted. And for the above problem statement, we came up with an idea approach that which helps us segregate the water, drinking water, and irrigation water, and also we can determine the amount of volume that can be added to purify the certain amount of water. So here is our project title, that is groundwater purification purity prediction using the machine learning algorithms. So this we all know that the groundwater will be is being stored by using the sources like rain and other entities. So that groundwater is being pumped by using bore pipes, and using motor will be pumping all the water from the ground. That water will be stored in the tanks, overhead tanks, which will be measured, which we can be able to measure the volume and height of the water by using certain scales. So we can be able to measure the purity of the water by measuring the pH scale by the above entities like pH scales, hardness of the water, solids present in it, chromines, and sulfates in it, measuring the conductivity of the water, presentation of organic compounds in the organic carbons in the water, trihalomethanes present in the water, and turbidity property of the water samples. We can be able to give all the above data and statistics to the machine learning algorithm which we have coded, and and our algorithm classifies the water into which is able to be drink, which is feasible for drinking, or it is not feasible for drinking. So in addition to it, we are able to predict the amount of alum that can be added to the water, which makes the water pure. Alum is a substance which is used for extracting all the or extracting or set to make the other particles settle down, which makes the water pure for drinking. So it is said that it is needed only 7.5 grams of alum for each liter of water. So our algorithm is able to detect how much amount of alum is needed for certain amount of water in the tank, and also our algorithm predicts how much water can be used for irrigation and how much water is used for irrigation for drinking household drinking purposes. Hmm. And that sense, hi guys, welcome to coding session. In this coding session, let us see the code for groundwater purity prediction ML project. Here, in this first slide, we are going to import all the modules which are required for our machine learning project. In the data gathering, by using read CSV module from pandas, we will be importing the certain data sets like water property CSV, alum CSV, and uh, household irrigation CSV. We'll be detecting the data sets for detecting the data for our project. In exploratory data analysis, we'll be detecting the how many null values and null cells are there in the data set, and what data types are being used for each data set, mean, median, and minimum and maximum amount of data present in each data frame will be calculated here. In this predicted data from the given inputs, we'll be detect we can calculate the amount of volume that can be added for each certain amount of water. So let us suppose give an input like enter here it is asking enter the volume of the water. We are giving 200. It is giving like 1,500 amount of 1,500 grams of volume can be added for purifying the 200 liters of water. In the same way, we can also detect the amount of water that can be used for drinking and amount of water that can be used for irrigation. I'm giving the same input as the 200. It is giving the input output as the amount of water that can be used for household is 200, and amount of water that can be used for irrigation is 0. Here we have also represented a graphical representation which are needed for our project development and testing analysis. And finally, we can also predict the data purity of the project of our algorithm by inputting the data of pH, hardness. So here we can take the inputs of pH, hardness, and other entities which we compare for calculating the feasibility of the drinking water. So we have given certain values to the as input. It is giving as answer as 1. 1 means it is feasible for drinking. Now let us also check for the bad drinking water. I'm giving all the values as 0. Probably the zero pH is not feasible for drinking. It is giving this value as zero, output as zero. That is not feasible for drinking. And also, upon testing our test efficiency, we got a training score as 89 point some, 59 something, and also the testing score as 81.082. Thank you for watching.